This video is for 6.2. It talks about sequences, both arithmetic and geometric. Um, let's start with number 1. Below is a table of values of a function. Write the output when the input is n. Okay, so what this is asking for is, okay, we have 4, 5, 8. What happens with 4? Well, from 4 to 1, we can either divide by 4 or minus 3. Okay, if we look at the next one, we see that one's minus 3. So I'm assuming this is the sequence here. So to get from 8 to 5, I also minus 3. That tells me that if I have n, I would have n minus 3, just like that. All you got to do is figure out what the pattern is, and then you just do the pattern to n. In this one, try to remember that input is always x, output is always y. We don't see any set pattern going from input to output. So what we need to look at then is, do we see a pattern for the outputs? Okay, and I do. It's always plus 3. Plus 3, plus 3, plus 3. And we can deal with this a different way. Now, inputs are always x, so here we have 1 comma 1 because the outputs are y. 2 comma 4. 3 comma 7. 4 comma 10. And what it's looking for right here is the equation. You know, we have y equals, and what it wants is the mx plus b. That's what it wants. So with that in mind, let's see what the pattern is. Y equals, and this is the first term, second term, third term, fourth term, so we don't need to worry about the x's so much. What's going on here? We see it's plus 3. And here it is also plus 3. And here it's also plus 3. How do I know it's plus 3? Well, I'm told right here it's a linear function. Linear functions means arithmetic sequence, so it's always going to be plus. So I have y equals 3x, okay, because that's our slope, that's our rate of change is 3. Now what would be our 0 term right here? So it goes minus 3, minus 3, minus 3. It would be negative 2. So minus 2. Okay. Now instead of x right here, we're going to plug in n. Because it doesn't want us to use x, it just wants us to use n. So I'm going to type that middle part right there, the mx plus b, right here. So 3n minus 2. Just like that. 3x minus 2, we change the x for an n, 3n minus 2. So with one this difficult, you just find the pattern and find the equation. Okay? Remember, this first part right here is just your rate of change. It's how much the y's are changing. This part right here is just your 0 term right there. An arithmetic sequence is shown. Okay? Arithmetic means it's a y equals mx plus b. Okay? Y equals mx plus b. And what we're looking for is the m, which is the rate of change, and the b, this part right here, which is the 0 term. So what's happening here? We have 12 to 17. That looks like plus 5, and plus 5. So we see the rate of change is plus 5. That's good. That's what we want to know. So that would make that positive 5x, because that's our rate of change. We add 5 each time. Okay, now what's our 0 term? Well, this is our first term. This is our second term, third term, fourth term. So our 0 term would be the one right over here, the invisible number. Well, if it's plus 5 going that way, let's just find the other way. Or it's the first term minus the common difference, which would be 7. Let's double check that. 27 minus 5 is 22. 22 minus 5 is 17. 17 minus 5 is 12. 12 minus 5 is 7. So that means I've got positive 7 right there. And that's what you need to put in. I mean, don't worry about the a sub n and stuff like that. Remember, a sub n is just y. So 5x plus 7. That's all you need to do. Oh, instead of x, it wants us to use n. 5n plus 7. And that's easy to do, but just remember, it wants the nth term, and that n right there, yeah, that n is what needs to go in right there. Okay, same thing here, y equals mx plus b, so what's going on? We're going minus 6, minus 6, minus 6, so we've got minus 6 as our change. So y equals minus 6x, and what would our other number be? So we've got plus 6 here, plus 6, plus 6. What's 21 plus 6? And that would be 27. Because remember, that's our first term, second term, third term. So the 0 term is right before. So plus 27, because that's a positive 27. So that tells me that the equation is negative 6, and it wants it as n, again, negative 6n plus 27. All right, so we need to decide if these sequences are arithmetic or geometric. Arithmetic has a common difference, or it adds and subtracts. Okay, geometric has a common ratio, which means it either multiplies or divides. Okay, so if we look at all of that and we say, okay, what's going on here? From 6 to 11, let's try adding. It's plus 5, plus 5. It's plus 5 both times, so right there. And right here, it's times 3 times 3. So geometric. How do I know it's not plus? Well, if I look at that, I could say, well, it's plus 18, but that is not plus 18. So it can't be arithmetic, so I double check the geometric and see 6 times what is 4. Now, if you don't know how to do that in your head, to find if it's arithmetic, you just subtract backwards. So 16 minus 11 is 5. 11 minus 6 is 5. If you get that each time when you subtract backwards, then you know it's arithmetic. Here, if I subtract, I get, I don't even know what it is. I can't do it in my head. Looks like 72. Well, 24 minus 72 is not 6. So we can't subtract. So now we divide. Okay, the opposite of plus is subtract. The opposite of times is divide. So if you divide backwards, then you get that. 96 divided by 24 is 4. 24 divided by 6 is 4. So that common ratio is 4. This common difference is 5. And we use that to write our equations. So for the arithmetic, it's a y equals mx plus b. And what's going on here? We have the slope, y equals 5x. The 5 is the difference right here. Okay, so that's where I'm getting the 5. And what's our 0 term? Well, minus 5, what would be the next one here? It would be 1, because 6 minus 5 is 1. So plus 1. So that gives me my equation for here. 5, and in this case it wants us to use n. 5n plus 1. How do I know it wants me to use n? Right here, it puts the n. So whatever's right here, the subscript below a, is what it wants me to use for x. That's my x term. So instead of x, I'm replacing it with n. Okay? So there's my nth formula there. Now, geometric formula, that one's slightly different. The geometric formula is where we take our first term times the ratio, the common ratio, to the n minus 1. Okay, so what's our first term? Our first term is 6. So I have 6 times, what's my common ratio? We found the ratio, we're dividing or multiplying by 4 each time, so we're multiplying by 4. N minus 1. And that's our answer. We're not asked to find a specific term, so we just put it in just the way we see it here. 6 times 4 raised to the n minus 1. And we're going to do this one more time. Let's find out if it's arithmetic or geometric. Okay. If it's arithmetic, it would go back, it would be the same. So how do I get from 6 to 18? Well, 18 minus 6 is 12. So plus 12, is 18 plus 12 54? No, it's not. So it's not arithmetic. That leaves only one option, geometric. So let's find out what the difference is. 18 divided by 6 is 3. 54 divided by 18 is 3. So my common ratio is 3, and my first term is 6. And that means I do the first term times the ratio to the n minus 1, just like that. So what's my first term? My first term is 6 times my ratio would be 3. Oh, instead of putting an r, I'll put a 3 to the n minus 1. And that's the answer. That's all you have to do. So 6 times 3 to the n minus 1. Okay, now let's look at this one. How do I get from 16 to 20? I can plus 4. And 20 to 24 is plus 4, so my difference is plus 4. Let's just say difference equals 4, positive 4. It's not geometric because it's adding. Okay, if my difference is 4, then that means I need to use the y equals mx plus b, where m is the difference, and b is the zero term. Okay, so what's our zero term? If I go one more that direction, it would be 12. Okay, so that gives me y equals, and what's my common difference? Is 4. And instead of x, it wants me to use n, and then positive 12. And that is what I got to put here, 4n plus 12. And that's how you do number 5 and 6. Hopefully this helps. Let me know if you have any questions.